Today, we're going to look at a pretty amazing piece of engineering. I mean, think about it. A factory is pumping out a constant stream of really toxic waste. What if you could design a system that makes that toxin just disappear? Well, we're going to break down exactly how a team of engineers did just that, turning a super hazardous problem into a remarkably clean solution.
So let's get right to the heart of it. The big question is this: how do you deal with industrial cyanide? This stuff is, famously dangerous, and it's a byproduct in a lot of industries. So how do you take water that's full of it and make it completely safe? How do you literally make the cyanide just vanish? And this isn't some theoretical problem. A real factory in Thailand was dealing with this every single day. We're talking a staggering 27.5 tons of this hazardous wastewater daily. The folks who stepped up to tackle this massive challenge were XCon Technology, a company that specializes in exactly this kind of high-stakes environmental engineering. So how in the world did they pull it off? Well, we're going to follow their playbook, step by step. First, we'll get a handle on just how big this problem was. Then, we'll look at the incredibly ambitious goal they set for themselves. We'll dive into their two-phase plan for destroying the poison and then purifying the water. We'll even check out the cool tech they used. And finally, we'll talk about the big picture. Why does this all matter so much?
All right, let's start by looking this challenge right in the eye. Industrial waste can sound a little abstract, but in this case, we're talking about some very real and very, very big numbers. To put 27.5 tons into perspective for you, that's roughly the weight of 4 big African elephants. I want you to imagine 4 elephants worth of toxic, cyanide-filled water coming out of one factory every single day. That's the toxic tide they had to tame.
Now, when the engineers looked at this problem, they didn't just aim for good enough. They went for the absolute gold standard in sustainable manufacturing, a concept they call Zero Liquid Discharge.
So what exactly is Zero Liquid Discharge, or ZLD? Well, it's pretty much what it sounds like. The goal isn't just to clean the water so you can dump it somewhere. The mission is to purify and recycle all of it, 100%. So absolutely no liquid waste ever leaves the factory. The only thing left behind is a small chunk of solid, dry residue. It's a true closed-loop system.
Okay, so to get to that zero discharge goal, you can't just start filtering. No way. First, you've got to deal with the most dangerous thing in the water. You have to neutralize the main threat, the cyanide itself, and that's phase 1. So how do they do it? They use something called an advanced oxidation process. It's actually pretty cool. First, they gather up all the contaminated water in a big tank. Then, under just the right conditions, they pump in ozone. Now, you can think of ozone as like supercharged oxygen. It's incredibly reactive, and it literally just attacks the cyanide molecules, ripping them apart and turning them into harmless stuff. Once that chemical battle is over, the water is moved to another tank, ready for the next stage.
And the result of this first phase? It's just incredible. You start with water that's loaded with free cyanide, and afterwards, the cyanide is completely, totally non-detectable. It's just gone. Now, that's a massive win, but it's only half the battle.
All right, on to phase 2. With the cyanide neutralized, the mission totally changes. Now, it's all about purification. The goal is to get everything else, all the salts, any other leftover chemicals, out of there and reclaim as much pure, clean water as humanly possible. This part is a 3-step journey to perfectly pure water. First, as you can see, they use an evaporator. Just think of it like a giant industrial-sized kettle. It boils the water, which leaves all the salts and other gunk behind, and then it collects the clean steam. That steam cools back down into pure distilled water. Then, that water gets a final polish. They use a little more ozone and a system called reverse osmosis, which is basically a super fine filter to catch any last little bits. And finally, whatever concentrated gunk is left over from the original wastewater gets dried into a solid, easy-to-handle block.
And here is the final box score. I mean, just look at this. It is amazing. 98% of that toxic sludge is turned back into clean, reusable water. That daily flood of poison becomes a valuable resource for the factory. And the other 2%? That's all that's left. Just a small amount of dry, solid waste that's totally safe to handle and dispose of. Incredible.
Of course, to pull off a process this sophisticated, you need some seriously advanced hardware. So let's take a quick peek at the high-tech toolkit that makes all of this magic happen.
At the very heart of Phase 1 is the ozone generator, and the one they're using here is a real beast. It's designed to be crazy efficient, using up to 25% less energy. It's also really compact, which, believe me, is a huge deal on a crowded factory floor. And it's built like a tank, so it can handle all the heat and vibrations of a tough industrial setting. These aren't just fancy features, they make the whole process cheaper and way more reliable.
So where does all the oxygen come from to make that ozone? Well, this is one of the cleverest parts of the whole system. Instead of messing around with dangerous, expensive tanks of liquid oxygen, they just make their own, right there on site. The system literally just pulls oxygen right out of the air. This is such a smart move. It's way safer, there's zero waste, and it means the factory isn't dependent on outside suppliers. It's a perfect example of really elegant, practical engineering.
So, we've seen the problem, we've seen the process, and we've seen the tech. But let's zoom out for a second. Why is a system like this so important? What does it really mean for the future?
You know, this quote from Zepcon's core values really just says it all. This entire process isn't just about cleaning up a mess. It represents a totally different way of thinking about how we make things. It's all about shrinking your environmental footprint while squeezing every last drop of value out of the resources you use. It's about turning a dangerous problem into a genuinely valuable solution.
And that brings us to the big, final question. We've just seen how this kind of technology can solve one of the most difficult wastewater problems you could possibly imagine. So, as we all move into a future where resources are getting scarcer and environmental rules are getting stricter, could this kind of closed-loop, zero-waste system become the new standard for all manufacturing? Something to think about, right? Thanks for checking out this explainer.